We'll now learn about Amazon Simple Storage Service, or Amazon S3. Amazon S3 is a regionally provisioned object storage service that stores content in buckets. The term bucket is used because S3 takes a different approach with the file storage. Instead of a folder, you create a bucket. A bucket is a large space that can hold any number of objects, and each bucket name is globally unique. To access data in a bucket, you can use the S3 API or direct HTTP calls. In the example, the client uses an S3 AWS CLI command, such as AWS S3CP or copy. This command issues an HTTP GET method to retrieve an object from an S3 bucket. All content in Amazon S3 is web-enabled. When you store an object in S3, it is automatically assigned a unique URL that includes the bucket name and the object's unique key. However, by default, all objects are private and protected by permissions to prevent them from being exposed to the public. S3 is also designed to be durable and highly available. This is because it automatically replicates content to multiple devices in a region, and also across multiple regions. As an example, consider the 11 nines of durability for content. This number means that if you stored 10,000 objects in S3, it would, on the average, lose one object once every 10 million years. On the availability side, the 4 nines means that you can reach your data when you need it with as little as 9 seconds of potential downtime per day. Finally, you can store as many objects as you want in an S3 bucket. Each object can contain up to 5 terabytes of data. Amazon S3 provides versioning to protect objects from accidental overwrites and deletes. Versioning enables you to easily recover from both unintended user actions and application failures. You enable versioning at the bucket level. Each object in a bucket has a version ID. When versioning is disabled, its value is set to null. When you enable versioning and you upload a new version of an object, S3 creates a new object and assigns a unique value to its version ID by incrementing it. An S3 bucket can be in one of 3 versioning states. First, the bucket can be disabled. This is the default setting. If you upload an object to a bucket with the same key, it overwrites the old version. If you delete an object, it is permanently deleted. Second, the bucket can be versioning enabled. If you delete an object, S3 logically deletes it and adds a marker. However, the old version is still retrievable by its version ID. And finally, you can set a bucket to versioning suspended. In this mode, the versions of existing objects are maintained, but the bucket temporarily behaves like versioning was disabled. Remember, when versioning is enabled on a bucket, it cannot be disabled. Versioning can only be suspended. Amazon S3 offers a range of storage classes designed for different use cases and requirements for access performance. Amazon S3 Standard is for general performance storage of frequently accessed data. Amazon S3 Intelligent Tiering is for data with unknown or changing access patterns. You can also choose Amazon S3 Standard Infrequent Access and Amazon S3 One Zone Infrequent Access for long-lived but less frequently accessed data. And finally, you can choose Amazon S3 Glacier for long-term archives and digital preservation. For more information about S3 storage classes, search for it in the AWS online documentation. The Amazon S3 Intelligent Tiering Storage class optimizes costs by automatically moving data to the most cost-effective access tier, without performance impact or operational overhead. It works by storing objects in 2 access tiers. One tier is optimized for frequent access, and another lower-cost tier is optimized for infrequent access. S3 monitors the access patterns of the objects. It moves the objects that have not been accessed for 30 consecutive days to the infrequent access tier. If an object in the infrequent access tier is accessed, it is automatically moved back to the frequent access tier. As we mentioned before, S3 Intelligent Tiering works well for storing long-lived data with access patterns that are unknown or unpredictable. By default, new buckets and objects in Amazon S3 do not allow public access. However, users can modify bucket policies or object permissions to allow it. If you want to block the effect of these resource-based policies, S3 provides block public access settings for buckets and accounts to help manage public access to S3 resources. Amazon S3 Block Public Access provides settings that override resource-based policies and permissions so that you can limit public access to resources. With Block Public Access, account administrators and bucket owners can easily set up centralized controls to limit public access to their S3 resources. These controls are enforced regardless of how the resources are created. As a best practice, public access should only be used for S3 web hosting. You can set up Block Public Access feature from the S3 console with the AWS CLI or S3 APIs. You can also set this up with an AWS CloudFormation template. Amazon S3 Block Public Access provides 4 settings. First, you can block new public access control lists or ACLs and uploading public objects. This option disallows the use of new public bucket or object ACLs. It is designed so that future put requests will fail. It does not affect existing buckets or objects. Use this setting to protect against future attempts to use ACLs to make buckets or objects public. The action is blocked if an application tries to upload an object with a public ACL, or if an administrator tries to apply a public access setting to the bucket. Next, you can remove public access granted through public ACLs. This option tells S3 not to evaluate any public ACL when it authorizes a request, which means that buckets or objects cannot be made public by using ACLs. This setting overrides any current or future public access settings for existing and future objects in the bucket. If an existing application can currently upload objects with public ACLs to the bucket, this setting will block the action. Another option is to block new public bucket policies. This option disallows the use of new public bucket policies. This means that future put requests that include them will fail. However, this does not affect existing buckets or objects. This setting is designed so that a bucket policy cannot be updated to grant public access. Finally, you can block public and cross-account access to buckets that have public policies. Choosing this option limits access to buckets that are publicly accessible to the bucket owner and to AWS services. You can select this option to protect buckets that have public policies while you remove the policies. That way, you can prevent information that is stored in a bucket by an AWS service from becoming publicly accessible. Amazon S3 Object Lock enables you to store objects using the write once, read many, or worm model. You can use Object Lock to prevent an object from being deleted or overwritten for either a fixed amount of time or indefinitely. Object Lock enables you to meet regulatory requirements that require worm storage. You can also use it to add an additional layer of protection against object changes and deletion. You can manage object retention in 2 ways. With retention periods, you can specify a fixed period of time for the object to be locked. During this period, the object will be worm protected and can't be overwritten or deleted. You can also set a legal hold, which provides the same protection as a retention period, but has no expiration date. A legal hold remains in place until you explicitly remove it. Legal holds are independent from retention periods. An object version can have both a retention period and a legal hold, one but not the other, or neither. Compliance won't allow any user to overwrite or delete an object. Governance mode allows graceful access for the users you choose while preventing other users from overwriting or deleting an object. You can configure the Amazon S3 event notification feature so a bucket sends notifications when a new object is added to or deleted from the bucket, or when an existing object is overwritten. These notifications can be sent to Amazon Simple Queue Service, or Amazon SQS, Amazon Simple Notification Service, or Amazon SNS, or AWS Lambda. You can configure notifications so they are filtered by the prefix and suffix of the key name of objects. For example, you can set up a configuration so that it sends only a notification when image files with a JPEG extension are added to a bucket. Or you can have a configuration that delivers notifications to different services. For example, an SNS topic can be notified when an object with the prefix images is added to the bucket. Also, an AWS Lambda function can be notified when objects with a logs prefix are added to the same bucket. This table lists some additional features that Amazon S3 offers, identifies their purpose, and outlines how they are used. Object Lifecycle Management enables you to manage your objects so that they are stored cost-effectively throughout their lifecycle. By creating a lifecycle configuration, you can define rules that specify actions that S3 automatically applies to a group of objects. There are two types of actions. First, you can set transition actions, which define when objects transition to another storage class. For example, you might choose to transition objects to the standard infrequent access storage class 30 days after you created them. You might also choose to archive objects to the Glacier storage class 1 year after you created them. You can also set up expiration actions. These actions define when objects expire. S3 deletes expired objects on your behalf. You can create a pre-signed object URL to give someone access to an object for a specified duration. You can generate a pre-signed URL programmatically using the AWS SDK for Java or the AWS SDK for .NET. If you are using an S3 bucket to host a static website, you can take advantage of cross-origin resource sharing, or CORS. This enables the web application to access a resource from a domain that is different from the domain of the bucket's endpoint. By default, browsers block these requests to enforce a same domain origin policy. CORS defines a way for a client web application that is loaded in one domain to interact with resources in a different domain. A CORS configuration is an XML document with rules that identify the origins you allow to access your bucket. The CORS document also specifies the allowable operations, or HTTP method, for each origin and other operation-specific information. As a general rule, you use the S3 URI prefix to address an object in a bucket in a command. The S3 AWS CLI command here creates an S3 bucket named myBucket. It also displays the command to list all buckets in an AWS account, which is AWS S3 LS. For more information about S3 AWS CLI commands, search for CLI services, S3 commands, and the AWS online documentation. The first example here copies a file named file.txt in the current local directory to the bucket named myBucket under the prefix myPrefix. The second example shows how to use the AWS S3 sync command to synchronize the contents of both locations. The changes will be synchronized if the contents of the file change, or the contents of either the local directory or the bucket prefix location change. Finally, the third example shows the command to remove the file from the S3 bucket. Use the storage class option on the copy command to create an object with a different storage class than the default class, which is standard. The example command creates an object named file.txt in myBucket under the myPrefix with a storage class of intelligent tiering. Use the storage class option on the copy command to create an object with a different storage class than the default class, which is standard. The example command creates an object named file.txt in myBucket under the myPrefix with a storage class of intelligent tiering. While the S3 CLI commands are fine for simple use cases, they do not expose the full feature set of Amazon S3. To gain access to advanced features, use the AWS S3 API command instead. S3 API supports manipulating the full range of data and metadata associated with S3 buckets and objects, including bucket policies, ACLs, multi-part uploads, and versioning. Thanks for watching. We'll see you in the next video. We will now learn about Amazon S3 Glacier and AWS Storage Gateway. We will also review two different data transfer and migration services. Amazon S3 Glacier is a secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backup. Like Amazon S3, it is designed to deliver 11 nines of durability. S3 Glacier provides comprehensive security and compliance capabilities that can help you meet stringent regulatory requirements. You store and retrieve data in S3 Glacier by using the AWS CLI or writing code that calls the S3 Glacier APIs. You can also use the S3 lifecycle rules to automatically move objects from S3 to S3 Glacier. S3 Glacier does not have console support for archive operations. With Amazon S3 Glacier, you can archive objects such as a document, a video, or any other type of file. An individual object archived into S3 Glacier is referred to as an archive. Each archive has a unique ID assigned to it. Archives are stored in vaults. A vault is addressed by the unique name assigned to it by its creator. A given AWS account can create up to 1,000 vaults in S3 Glacier. You reference archives in S3 Glacier through a URL that points to the S3 Glacier service. The URL contains three components: the account ID of the owning AWS account, the name of the vault, and the ID of the individual archive. In the example, an application stores an archive identified by the archive ID in the vault named Example Vault under the prefix Archives. It is in the Amazon S3 Glacier service for the example account, which runs in the US East 1 region. You can use two ways to interact with objects in Amazon S3 Glacier. First, you can use an Amazon S3 lifecycle policy. Secondly, you can use the S3 Glacier API via custom code. With an Amazon S3 lifecycle policy, you can automatically move an object to S3 Glacier by specifying a transition action to change its storage class to Glacier. Data stored in S3 Glacier by lifecycle policy cannot be directly retrieved by using the S3 Glacier API. Instead, this is data that S3 manages on your behalf. It will not show up as a vault or a set of archives. Files archived by a lifecycle policy can be restored with the S3 console or by using the S3 API. You can also upload, retrieve, and manage files through the S3 Glacier API. Retrieving an archive from S3 Glacier is an asynchronous operation. First, you initiate a job, and then download the output after the job completes. To initiate an archive retrieval job, you can use the Initiate Job, also known as Post Jobs, REST API, or the equivalent command or feature in the CLI or SDKs. A retrieval request can get a single archive by using an archive ID, multiple archives by specifying a creation date range, or a subset of an archive by specifying a byte range. You can poll for job completion by using the describe job, the get job ID API function. You can also send S3 Glacier completion notifications with Amazon SNS. After an S3 Glacier job is finished, you can request a download of their stored data. In addition, you can run analytics directly on your archive data with the Query in Place function. Glacier Select. To use it, specify the select operation when you initiate a job request. With Glacier Select, you can run queries and custom analytics on the data you store in Glacier without needing to restore it to S3. To keep costs low, but still suitable for various retrieval needs, Amazon S3 Glacier provides three options for accessing archives. These options have retrieval times that range from a few minutes to several hours. The first option is expedited retrievals. This option enables you to quickly access your data when you must respond to occasional urgent requests for a subset of archives. Data accessed through expedited retrievals are typically available within 1 to 5 minutes for all but the largest archives, which are 250 megabytes or more. There are two types of expedited retrievals: on-demand and provision capacity. On-demand requests are available most of the time. Provision capacity requests are guaranteed to be available when you need them. The next option is standard retrievals. They enable you to access your archives within several hours. Standard retrievals typically complete within 3 to 5 hours. This is the default option for retrieval requests that do not specify the retrieval option. Finally, you can use bulk retrievals to retrieve large amounts of data inexpensively in a day, including petabytes of data. Bulk retrievals typically complete within 5 to 12 hours. For more information about retrieving S3 Glacier archives, search for Downloading an Archive in the AWS online documentation. We will now review AWS Storage Gateway. AWS Storage Gateway simplifies the on-premises adoption of AWS storage. Storage Gateway is a hybrid storage service that enables your on-premises applications to use AWS cloud storage. You can use the service for backup and archiving, disaster recovery, cloud data processing, storage tiering, and migrations. Your applications connect to the service through a virtual machine or hardware gateway appliance that uses a standard storage protocols such as NFS, SMB, and iSCSI. The gateway connects to AWS storage services such as Amazon S3 or S3 Glacier. These services provide storage for files, volumes, and virtual tapes in AWS. Storage Gateway offers 3 interface types, which are the File Gateway, Volume Gateway, and Tape Gateway. The service includes a highly optimized data transfer mechanism that offers bandwidth management, automated network resilience, and efficient data transfer. Also, the service offers a local cache for low latency on-premises access to your most active data. The AWS Storage Gateway file interface enables you to store and retrieve objects in Amazon S3 by using the NFS or SMB protocol. After your files are transferred to S3, they are stored as objects and accessed through an NFS mount point. Here they can be managed as native S3 objects. Thus, they benefit from features such as versioning, lifecycle management, including archive to S3 Glacier, and cross-region replication. The AWS Storage Gateway Volume interface presents your applications with block storage disk volumes that you can access by using the iSCSI protocol. Data on these volumes are backed up as point-in-time EBS snapshots that you can access through Amazon EC2 if needed. When you connect to this block interface, you can run the gateway in 2 different modes. With cached mode, your primary data is stored in S3 and you retain your frequently accessed data locally. This results in substantial cost savings for primary storage. It minimizes the need to scale your on-premises storage, but it also retains low latency access to your frequently accessed data. In stored mode, you store your entire data set locally, but you perform asynchronous backups of this data to S3. This provides durable and inexpensive off-site backups that you can recover either locally or from EC2. The AWS Storage Gateway Tape interface presents the storage gateway to your existing backup application as a virtual tape library. The tape library consists of a virtual media changer and virtual tape drives. You can continue to use your existing backup applications while you write to an almost limitless collection of virtual tapes. Each virtual tape is stored in S3. When you no longer need access to data on virtual tapes, your backup application can archive it from the virtual tape library to S3 Glacier. This further reduces your storage costs. Now we will review 3 different services for migrating and transferring data to AWS. AWS Transfer for SFTP is a fully managed service that enables the transfer of files directly into and out of S3 by using the Secure File Transfer Protocol. This service creates an SFTP endpoint to securely exchange data. It also manages the infrastructure that supports it to maintain high availability and scalability. Because SFTP is a popular protocol, AWS Transfer for SFTP can help you migrate your file transfer workflows to AWS. It integrates with your Microsoft Active Directory or other identity system and with key AWS services, such as Route 53. You can use this service to migrate your SFTP-based workflows to AWS without changing your existing authentication systems, domains, or host names. In addition, your external customers can continue to exchange files with you without changing their applications, processes, or client software configurations. AWS Data Sync is a data transfer service that simplifies, automates, and accelerates moving and replicating data between on-premises storage systems and AWS storage services. It is a fully managed service that automatically handles many data transfer tasks that can slow down migrations or burden IT operations. For example, the service automatically performs data encryption, network optimization, and data integrity validation. Data Sync uses a purpose-built network protocol and a parallel multi-threaded architecture to accelerate transfers. The service works well for both one-time data migrations and recurring data processing workflows. It can also be used for automated replication for backup and recovery purposes. To learn more about how to choose between Data Sync and Storage Gateway, search for Data Sync Frequently Asked Questions on the AWS homepage. This diagram shows a high-level view of the Data Sync architecture. To use Data Sync, you deploy the Data Sync agent in your on-premises system. Then you connect the agent to a file system or storage array. Finally, you select either EFS or S3 as your AWS storage and start moving data. The Data Sync agent connects to your existing storage or file systems using the NFS protocol. Data is encrypted using Transport Layer Security or TLS as it moves between on-premises storage and AWS cloud storage. Data Sync can copy data to AWS over either Direct Connect or Internet links. AWS Snowball is a solution for customers that have large-scale data transfer challenges. It is a petabyte-scale data transport solution that uses secure appliances to transfer large amounts of data into and out of the AWS cloud. Using Snowball addresses common challenges with large-scale data transfers, including high network costs, long transfer times, and security concerns. Transferring data with Snowball is simple, fast, and secure. It can cost as little as 1/5 the cost of high-speed internet. To use Snowball, create a job in the AWS Management Console. A Snowball appliance will be automatically shipped to you. After it arrives, attach the appliance to your local network and download and run the Snowball client to establish a connection. Then, use the client to select the file directories that you want to transfer to the appliance. The client encrypts and transfers the files to the appliance at high speed. After the transfer is complete and the appliance is ready to be returned, the electronic shipping label automatically updates. You can track the job status via Amazon SNS, text messages, or directly in the console. Snowball uses multiple layers of security designed to protect your data. Security measures include tamper-resistant enclosures, 256-bit encryption, and an open standard trusted platform module that is designed to provide both security and full